In this problem, we got an equilateral triangle ABC with all sides measuring 4 by 3 root 6, 4 by 3 root 6. And then a semicircle that exactly fits inside this equilateral triangle. In fact, it is the semicircle with the greatest area that can be fitted inside this equilateral triangle. The question is, find the area of the semicircle or find the area of the shaded region. Let us erase something that is not necessary for us. Observe that semicircle intersect the equilateral triangle at exactly one point, let's say T. Let O be the center of the semicircle. By symmetry, OA equal to OB, and if S denote the length of side of the equilateral triangle, then OA equal to OB equal to S by 2. Further, we join OT. Observe that OT is actually radius of the semicircle. And if we know the radius of semicircle, then area of semicircle equal to half of pi r square or half of area of circle. So the problem boils down to finding the radius of the semicircle. We know that angle B measures 60 degrees. After all, triangle is an equilateral triangle. And we just want to copy the length OB on the line segment BC. Let D be the point at a distance S by 2 from the point B. In other words, D is the middle point of CB. And then join OD. Since OB equal to DB equal to S by 2, this triangle is an isosceles triangle with this angle equal to this. And we observe that angle D plus 60 degree equal to 180 degree, or 2 times angle D equal to 120 degree, or angle D measures 60 degree. Or triangle OBD happens to be an equilateral triangle. Once again, we want to find the length of OT or the radius of the semicircle. As per the question, BC just touches the semicircle. Let us draw a circle and then draw a line segment that just touches the circle. What is this line segment? It is tangent to the circle. And we know that tangent is perpendicular to the radius at the point of contact. Or angle OTD is a right angle. Now, in triangle OTB and OTD, angle B and D both measure 60 degrees. They are equal. Angle OTD equal to angle OTB. They both measure 90 degrees. And OT equal to OT. In other words, those two triangles are congruent. If two triangles are congruent, then the length of TB must be equal to length of TD. Since D is middle point of CB, CD measures S by 2, and T is middle point of DB, DT measures S by 4. And since triangle OBD is an equilateral triangle, OD measures S by 2. Now consider the right angle triangle OTD and just apply Pythagoras theorem. Square of hypotenuse S by 2 whole thing square must be equal to square of perpendicular, that's R square, plus square of base, that is S by 4 whole thing square. And thus R square equal to S square by 4 minus S square by 16. Or R square equal to 4 number of S square by 16 minus S square by 16, or R square equal to 3 number of S square by 16. Now we got S to be 4 by 3 root 6. And so area of circle equal to half of pi r square. Instead of r square, we got 3 by 16 s square. That's equal to 3 pi by 32 times s square, and s square is 16 by 9 times 6. Hey, 16 times 2 is 32. You can cancel 3 out as well. You can cancel 6 out as well. And so area of semicircle is just pi square unit.